Good morning, dear students. I am Professor Priya Gulani from Department of Commerce. Today we are going to study the concept of dispersion. Now, as in the previous classes, we have already studied the measures of central tendency. Now, whether the measure of central tendency that we have calculated, the mean, median or mode, whether it is reliable or not, how to know? Now, to understand their reliability, we study the concept of dispersion. Now, let's see what is dispersion. Dispersion refers to the variations of the items among themselves or around an average, as I have already told you. Then, greater the variation among the different items of a series, the more will be the variation. According to Bowley, now Bowley has given a definition for dispersion. He says dispersion is a measure of variation of the items. So this is dispersion, the concept of dispersion. It tells us about the variations amongst the series or if compared with the measure of central tendency. Now the objectives of measuring dispersion. To determine the reliability of an average, as I've already told you, it determines the reliability of average. It compares the variability of two or more series. It can be used to compare the variability among two or more series. Then it facilitates the use of other statistical measures as well. Then it forms the basis of statistical quality control as well. Now these are the objectives for which we should study the concept of dispersion, other than comparing it with the average that we have calculated while we were studying the concept of measures of central tendency. Now, moving ahead, let us see what are the properties of a good measure of dispersion. It should be easy to understand, should be simple to calculate, it should not have so much calculations, it should be uniquely defined, it should be based on all the observations, then only it will hold true. Then it should not be affected by extreme values. It should be capable of further algebraic treatment. So these are the properties of a good measure of dispersion. Now, the measure of dispersion. The measures of dispersion are of two types: the absolute measures of dispersion and the relative measures of dispersion. Talking about absolute measures of dispersion, it is expressed in the same units in which the data is expressed. For example, rupees, kg, liter or kilometer. Talking about the relative measure of dispersion, it is in the form of a ratio or percentage. So it is independent of the units. The value will not be in rupees, kgs, liter or kilometer. It is going to be in a form of ratio or percentage. So it is also called the coefficient of dispersion. So when the question asks you about the coefficient of dispersion, it is talking about the relative measure. Now, what are the different methods of measuring dispersion? First of all, range, interquartile range or quartile deviation, mean deviation, standard deviation, coefficient of variation and Lorentz curve. These are the methods with which we can calculate the measures of dispersion. Let us first understand what is range. It is the most simplest measure of dispersion. It is defined as the difference between the largest and the smallest values in the given series. So whatever data we obtain, we first of all find out which is the largest value and which is the smallest value. And on the basis of the largest and the smallest value, we determine the range. So the formula for range is R is equal to L minus S. Range, R stands for range, L is the largest value and S is the smallest value. So the coefficient of range will be calculated like this. The smallest value will be subtracted from the largest value and it will be divided by the addition of both the values. In this way, we will be able to calculate the absolute measure of dispersion as well as the relative measure. It is going to be in the form of a ratio. Now let us see some practical problems based on range. See, in the first question, you have to determine the range and the coefficient of range for the given data. See, we have got 20, 35, 25, 30 and 15. So if we are able to observe here, the largest value is 35 and the smallest value is 15. So if we subtract 15 from 35, the answer is going to be 20. So 20 is the value of range, and when we divide 20 L minus S by the addition of both the values, the largest and the smallest. So the largest value is 35 and the smallest value is 15. When we add both these values, the sum is going to be 50. So when we divide 20 by 50, the answer is going to be 0.4. So it is in the form of ratio. So it is the relative measure of dispersion, and this is the absolute measure of dispersion. Again, we have got one more practical problem with us. So these are the values of x, and for the same values of x, we have got the frequency as well. Now this is a discrete series. Here you can see which is the largest value. The largest value is 70. We just need to observe the given values of x. So the largest value is 70 and the smallest value is 10. So when we subtract 10 from 70, the answer is going to be 60. And we have to divide 60 by the addition of both the values, that is 80. So when 60 divided by 80, the answer is going to be 0.75, which is the coefficient of range or the relative measure of dispersion. Similarly, one more question is there with us. Here we are having the group series, the smallest value being 5 and the largest value being 30. So when we subtract 5 from 30, the answer is going to be 25, which is the range. And when we divide this 25 by the addition of 30 and 35, the answer is going to be 5 by 7, which is in the form of ratio. So with these practical problems, we have understood how to calculate range for the all three types of series: the individual series, the discrete series, and the group series. Thank you.